Hey everybody, this is Alex Merced, and welcome to another video about data optimization. And again, if you guys like these videos, like, subscribe, and leave a comment, and follow me on Twitter and LinkedIn. But what I want to do today is talk about bloom filters. So bloom filters are another way to kind of speed up the ability to find information. Okay, so what a bloom filter does is that it creates a sequence of bits. So again, bits are just basically zeros and ones. So let's say we created a 6-bit bloom filter. So in this case, we start off with 0, 0, 0, 0. Okay, so 6 bits. Actually, let's make that as a string. 0, 0, 0, 0, 0, 0. Okay, so there's my 6-bit bloom filter. So essentially what happens is that every time you write, so if you do a bloom filter on a particular column, what it'll do is that it will take that value and then hash it. Okay, use a hash function, well, it'll use a function to see if it falls into one of these 6 spots. Okay, so essentially the function will always result in either, 1, 2, 3, 4, 5, 6. Okay, so let's say I go through these values, and let's say, we're doing it by name. So we're trying to figure out, hey, does a particular show exist in this? And actually, I want to duplicate this before I do that. Boop. Okay, for that next video. Okay. But in this case, I want to see, hey, does Baywatch exist? Or Baywatch exist? So I pass it to the hash function or the function. Okay. So we would pass Baywatch to that, which is then going to return, let's say, the value of 5 or the 5th spot. So in that case, what we do is we would then take the 5th spot, 1, 2, 3, 4, 5, and now mark that as 1, meaning there is a value in this data set that when it's passed to the hash function generates that particular spot. Okay, so we do know now there's a value that exists in this data set that hashes to that. Okay, so now, and then again, I would do this for this one. We'll say this one actually hashes to 5 as well. This one hashes to 3, so let's turn 3 into a 1. Okay, and then this also hashes to a 5. This hashes to, let's say, 2. So again, I'm just kind of just making it up as I go along as far as how they hash. Okay, and we'll pretend that the remaining ones, the end result is that this is what you end up with as your bloom filter. Okay, so in that case, basically I know that there are values that hash into spots 2, 3, 5, and 6. There are not values that hash into spots 1 and 3 and 1 and 4. So let's say I go and I do a search for family matters. Okay, so the way I would use this bloom filter is that we would hash family matters. Okay, and let's say family matters hashes into spot 5. Well, spot 5 is a 1, so that means it is possible that family matters is in this data set. We don't know that for sure, so again, you can have a false positive. Okay, so in that case, I would still end up searching for this and not finding it. But let's say I go then search for step by step, and that hashes to a 1. So the first step, that's still 0. So that means we know that at no point have we inserted a value that has ever hashed into that first bit. Okay, so in that case, we know that step by step unequivocally is not in this data set. Okay, so in that case, we can just skip the scanning of the data set, and that's how bloom filters help you out. They don't help you out with every value, but periodically they're going to be able to determine which values you just don't need to bother scanning. So in this case, bloom filters are oftentimes used in Parquet files, so that way you can just basically, if you know what value you're searching for, you can use the bloom filter to determine whether you need to scan the file at all, without necessarily needing an index or whatnot. So again, the indexes may not capture that specific value, but the bloom filter will let you know this value is definitely not in here. So that's all bloom filter is. Again, a bloom filter can be any number of bits. Okay, but again, the more bits, the more accurate it can be, because again, there's more possibilities. So in that case, there's more likely that the value you're searching for that's not in the data set is going to hash to a bit that hasn't been hashed before. But it also takes up more space. While a smaller bloom filter is going to give you much more false positives, but also takes up less space. So again, there's always that trade-off depending on again, how many, are you doing bloom filters on multiple rows? How many different possible values are there? So if there's like right now, if you're thinking, hey, like there's 10 possible values, well, then maybe a 6-bit bloom filter or a 3-bit bloom filter might be enough. Okay, but if, again, it just depends on sort of what your needs are. It also depends on particular where you're actually doing this, like what database, what file type, which are going to have support for different sort of types of bloom filters. So in that case, you don't necessarily always have the ability to just create the bloom filter you want. But that's essentially what it is. And again, you can get false positives, but you'll never get false negatives. And that's the beauty of it. You can always make sure that you can, when you get a negative, you know for sure that that is not in that data set, in that file, or in that table, depending on what kind of bloom filter you're using. So have a great day. My name is Alex Merced. Again, make sure to like and subscribe. I'll see y'all later.